While we are spending our days anxiously going through all the predictions about AI and software development, great things are actually still happening in the programming world. A few major releases have quietly happened in the web development world in the past couple of weeks, so in this Monday morning review, we'll go old school and discuss some of the recent updates in the JavaScript world. First of all, my favorite JS framework is finally reaching a stable version 2. SolidJS has officially entered the 2.0 beta phase after spending a surprisingly long time in what the team called an experimental phase. The release introduces several fundamental changes to how the framework handles reactivity, asynchronous work, and UI updates. The biggest conceptual shift is that asynchronous operations are now first-class citizens inside the reactive system. In Solid 1, asynchronous work was something you had to carefully orchestrate around a reactive graph. In Solid 2, computations can directly return promises or async iterables, and the reactive graph understands how to suspend and resume execution. This enables a more natural model for handling data fetching and background updates without constantly tearing down and rebuilding UI components. Another important addition is a new component called loading, which is designed specifically for handling the initial rendering state of a UI subtree. If a section of your interface cannot yet produce UI because it depends on asynchronous data, loading displays a fallback. Once the data is ready, the UI stabilizes and stays visible while background work continues to run. In other words, the loading state only affects the initial readiness of the UI rather than repeatedly interrupting it. Of course, this is not a new concept, and frameworks like React have had similar ideas for a while with suspense. Closely related to that is a new concept called pending UI expressions. Now, instead of managing loading flags scattered across components, you can ask the reactive system directly whether a piece of data is currently refreshing through the isPending helper. What's important is that this approach isn't tearing down the existing UI, so, in practice, the user interface stays stable while data refreshes in the background. This tends to produce smoother experiences than constantly switching between loading states and fully rendered components. The new action primitive is another great DX improvement which lets you describe the full lifecycle of a mutation in a single linear flow. Instead of scattering logic across event handlers, effects, and state updates, you can now define a generator function that walks through the process step by step. You start with an optimistic update, then perform the actual async work, and finally trigger a refresh of any derived state. And since we are talking about SolidJS, here is your awesome trivia for the day. Knockout.js is one of the OGs of front-end frameworks, and it introduced the concept of signal-based reactivity, which also influenced Solid and, in turn, the rest of the modern ecosystem we are using today. What's interesting is that last week, Knockout had its first update in 6 years. Granted, the update is small and mostly focused on keeping the framework compatible with modern tooling and browsers. But this is a good reminder that in software, a lot of the new ideas we keep reinventing every 2 years were already explored decades ago. So, despite all the hype cycles, we're still iterating on the same core ideas, and this applies to the entire tech industry, AI included. Back to the video, my second favorite JS framework has also reached a new major version. Astro 6 was recently released with a focus on removing friction. The main change is the dev server rewrite, and this is one of those updates that looks boring on paper but fixes a very real problem. Until now, Astro development has happened in a Node.js environment, even if you are targeting Cloudflare workers or Dino in production. This mismatch meant you were effectively developing against a simulation and hoping nothing broke when you deployed. And with Astro 6, this gap is gone. Thanks to Vite Environment API, the dev server now runs the same runtime as production. The Cloudflare integration in particular is a big deal. Before this, you had to deal with missing bindings, partial simulations, or awkward workarounds just to get something running locally. Now, the adapter runs workerd everywhere, which means you are no longer guessing how your app will behave in different environments. If you worked with fonts, you probably know that they seem straightforward on the surface, but if you want to do a good job, you actually have to think about performance trade-offs, privacy issues, preload strategies, and fallback generation. If we are being honest, everyone knows these things matter, but almost nobody commits the time to get things right consistently. But, starting with version 6, Astro now handles all of this for us. Once you declare a font, the framework downloads it, self-hosts it, generates fallbacks, and wires up preload hints automatically. Sure, this ain't much in the grand scheme of things, but Astro is in the habit of removing one of those small but persistent sources of friction that nobody enjoys dealing with. The same applies to content security policy now, which is one of those features that sounds important, gets mentioned in every security checklist, and then quietly gets ignored because nobody wants to deal with it. In short, CSP is a browser security mechanism that controls what your page is allowed to load and execute. You define a set of rules, usually through HTTP headers, that tell the browser which sources are trusted for things like scripts, styles, images, or fonts. Anything outside those rules gets blocked. The main goal is to prevent attacks like cross-site scripting, where malicious code gets injected into your page and executed in the user's browser. The problem is that modern applications are dynamic. Scripts are generated at runtime, styles are injected on the fly, and third-party integrations add their own resources. Keeping track of all of that and generating the correct hashes or allow lists quickly becomes tedious and error-prone. And now Astro abstracts that complexity away by automatically hashing your scripts and styles and generating the correct policy. Content collections are also changing. Up until now, they were tied to the build step, so you first had to define your content, run the build step, and everything was getting baked into the final output. This works well for static sites, but it breaks down the moment your content needs to change without triggering a full rebuild. Astro 6 introduces live content collections, which moves the process to request time. Now, instead of rebuilding your project every time something changes in your CMS or API, Astro can fetch that content on demand using the same APIs you were already using. And this is done in a seamless manner, allowing you to keep using the same collection definitions, the same schemas, and the same queries. The only difference is whether the data is resolved at build time or at request time. Since we are talking about the recent web news, I should also mention that TypeScript reached version 6, but this one is a rather small release, mostly meant as a bridge between 5.9 and the future native compiler written in Go that will power TypeScript 7. But probably the biggest front-end update in recent months is the release of Vite 8. Vite is powering most modern frameworks, and it manages to offer both a great dev experience and performance thanks to its dual architecture, where ESBuild was making development feel instant, while Rollup handled production builds. This was great for developers, but it also meant Vite was constantly juggling two different systems behind the scenes. With Vite 8, this model is gone, and the entire system now runs on a single bundler called Rolldown, written in Rust. Rolldown operates at native speed, and early benchmarks show production builds improving anywhere between 10 and 30 times compared to Rollup. More importantly, it achieves that without breaking the existing ecosystem. The plugin API remains compatible, so, in most cases, your current setup will continue to work without major changes. On top of the architectural changes, there are also a few smaller improvements that follow the same pattern we've seen with Astro. We now get built-in dev tools for debugging and analysis, native support for TypeScript path aliases, WebAssembly support in server-side rendering, and even the ability to forward browser console logs directly to your terminal, which makes a lot of sense if your workflow involves coding agents or remote environments. So, despite all the noise, great things are still happening in the dev world. If you like this video, you should consider joining our community, where I'm posting more dedicated weekly content. Please don't forget to smash all the buttons, and until next time, thank you for watching.